For lesson 10 in this chapter, we're going to take a look at reflections in the coordinate plane. And again, we've looked at reflections already this year. Again, they're just another type of rigid motion. But what we're going to do is just review a little bit and reflect across lines that are not the x-axis, y-axis, and just kind of review the harder stuff. So on the grid below, we have the point A, whose coordinates are 3, 7, and it's been plotted. What we want to do is find its image A prime after reflecting over each of the following lines. So first we're going to reflect over the x-axis, which is our horizontal axis. And remember, to do that, we basically just count how far away A is from the x-axis, in this case 7 units above, and then we're just going to put it 7 units below, and then that's going to be our A prime. So its coordinates are going to be 3, negative 7. If we reflect over the y-axis is our vertical axis, and so in this case we're 3 units away from the y-axis. We're going to go 3 units on the other side, and then that would bring A prime to the point negative 3, 7. And then we also said that we could reflect over any lines. In this case, they want us to reflect over x equals 6. So x equals 6, remember, is a line that only hits the x-axis at 6. It's not going to ever hit the y-axis. So if it's only going to hit the x-axis at 6, it's going to be a vertical line that looks something like that. And now if we want to reflect A over that line, x equals 6, we're 3 units away from that line. We're going to go 3 units to the other side. And so that point is going to be 9, 7. All right. And then we also want to reflect point A over the line y equals 4. So this is the line that only hits the y-axis at 4. So if it only hits the y-axis at 4, it's going to be a horizontal line that touches the y-axis at 4. And in this case, point A is 3 units above that line, and so we're going to bring it 3 units below. And that point is going to have the coordinates 3, 1. All right, so again, horizontal and vertical lines are easy to reflect over because it is rectangular in nature. But in exercise 2, we're going to just review some other properties about line reflections. So in the diagram at the right, we have point A that's been reflected across line M such that its image A prime is shown. Points A and A prime have been connected to form a segment AA prime, which intersects line M at point B. All right. So what is true about A prime, and M? Well, as we saw when we did our transformations, those two lines are perpendicular. So A prime is going to be perpendicular to line M. And then what is true about AB and A prime B? Well, we learned that those two segments are actually going to be congruent. So AB is going to be congruent to A prime B. And so we learned that M is the perpendicular bisector of that segment that connects an image to its pre-image. So we can use these facts to find coordinates for reflections over the line y equals x and y equals negative x, but first of all, let's make sure that we know where those lines are. So on the graph, we want to plot y equals x and y equals negative x. So we're going to state some points and then talk about the slopes. So if y has to equal x, so we're going to graph y equals x and y equals negative x. And so basically the first thing we want to do is state some points. So if y has to equal x, I know that if x is 1, y has to be 1. And if x is negative 2, y has to be negative 2. And if x is 10, y has to be 10. So no matter what x is, y has to be the same thing. And if we look at this as in slope-intercept form, y equals 1x plus 0, it looks like it's going to hit the y-axis at 0, and it's going to have a slope of 1. So to graph this point, or to plot this point, we know it has to hit the y-axis at 0, and then we can use some of our points like 1, 1, negative 2, 10, 10 if that would fit on our graph. Or we could also use the fact that it has to hit the y-axis at 0 and have a slope of 1. So up 1 over 1 a bunch of times is going to give us the equation, or the picture of that line. So that line is y equals x. Y equals negative x is where the x value and the y value are the same number, but they have different signs. So if x was 1, y would have to be negative 1. If x was negative 2, y would be positive 2. And the slope of this line, again, if we write it in slope-intercept form, it would be y equals negative 1x plus 0, so the slope of this line is a negative 1. So again, if we plot some of those points, 1, negative 1, negative 2, 2, that line, y equals negative x, is going to go from top corner to bottom corner, slanting down. All right, so on the back, now that we know where those lines are, let's actually do a reflection over them. And again, we did look at this earlier this year, but some people had a hard time with it, so we're going to revisit it again. So on the grid to the right, point A has been plotted along with y equals x, y equals negative x. Find the image of this point after a reflection over y equals x. So that's this line right here. So remember, what we want to do is draw a line that's perpendicular from A to that line. And in this case, we're basically traveling through the middle of those boxes. And so it looks like we're traveling through the middle of 4 of those boxes. And so we're going to do the same thing on the other side. And that'll give us A prime. Its coordinate is going to be 2, negative 6. Now if we reflect that same point over the line y equals negative x, we're reflecting it over this line. And again, what we want to do is travel perpendicular to that segment, so we're going to go right through the middle of those boxes, and it looks like we're going through the middle of 2 of those, and so we're going to go through the middle of 2 boxes on the other side to get our new A prime. And its coordinates are negative 2, positive 6. All right, so using the rules, or what we saw up above in those examples, let's try to come up with a rule. To reflect over the y-axis, or to reflect over the line y equals x, what happens to our coordinates? Well, actually, the point A prime started off at negative 6, 2, so we're just going to change that. That'll help us out a little bit. Okay, so now what happened to our points? Well, to reflect over the line y equals x, it looks like our y value came first, and then our x value came second. So to reflect over the line y equals x, we just take our x values and y values and switch them. To reflect over the line y equals negative x, it looks like we put our y value first, but we have to change the sign, so that's going to be negative y. And then our x value comes second, but we change the sign of that too. So really, when you reflect over y equals x, you just switch the coordinates. And when you reflect over y equals negative x, you switch the coordinates, but you also have to change the sign. All right, example number 6. This time we have the point 5, 3, negative 5, 3, and it's reflected over the line y equals x and then rotated 90 degrees counterclockwise about the origin, and then which of the following would be its final image point. So again, we want to take the point negative 5, 3, and we want to reflect it over the line y equals x, which is this one. And so basically that would be 1, 2, 3, 4, traveling through the middle of 4 of those boxes. So we're going to go 1, 2, 3, 4 in the opposite direction. And now what we want to do is rotate that 90 degrees counterclockwise. So I'm going to turn my paper 90 degrees counterclockwise. And this point right here is now at the point 5, 3. So this is my first one. That's what I got when I reflected it over y equals x, and then I rotated it 90 degrees. So I ended up at the point 5, 3. All right, and then the last one, this time it says reflections in lines other than the ones we've looked at are more difficult. The key though is that you want to make sure that you have lines that are perpendicular. So on the grid below, we have line M, whose equation is y equals 2x minus 3, and we have the point R, whose coordinates are negative 2, 3. If R was reflected over line M to produce an image R prime, what would be the slope of R prime? So we go back to perpendicular lines. So if lines are perpendicular, they're going to have negative reciprocal slopes. So if we have this line right here whose slope is a positive 2, the new line that goes from r to r prime would have to have a slope of negative 1/2. And it has to go through point r. So from here, we're going to go down 1 over 2, down 1 over 2. So we're going to do that twice to hit the line. And so basically we just want to carry that pattern on the other side. Down 1 over 2, down 1 over 2, we're going to do that twice, and r prime is going to be right there. So the coordinates of r prime are 1, 2, 3, 4, 5, 6, negative 1. And all we did there was used what we know about perpendicular lines and their slopes.